Hey Bobcats, it's Mr. Peterson. Today we're going to look at how we can solve quadratic equations using the quadratic formula, and also how we can use something called the discriminant to help us find roots. Now, on Friday in class, we figured out how we came up with the quadratic formula. We proved it in class using completing the square. So that's it right there. If you don't have it in your notes already, you should definitely copy it down. And a word of warning, when you solve problems using the quadratic formula, you definitely want to make sure that you've rewritten the equation in standard form before you start operating on it. And just another side note, the quadratic equation is one of many tools you have for solving quadratic problems. You also have factoring, you also have the square root property, you also have completing the square, and you have graphing. So those are other tools that you have. Quadratic formula is just one of them. The cool thing about this one is it works all the time. The bad thing about it is it's a little cumbersome, and there's a lot of numbers to write down and a lot of computation to do. But it works in every situation, whereas factoring does not always work for every quadratic equation. So let's look at a couple of them. So here we go. Find the zeros of x squared plus 10x plus 2. So I'm going to start off by rewriting my equation, set it equal to 0. So I have 0 is equal to x squared plus 10x plus 2. And I'm going to try to color code this as best as I can. It is in standard form. We have an ax squared plus bx plus c here. And so our leading coefficient is 1, which is okay with quadratics. You know, with completing the square, we can't have a leading coefficient. It's okay with the quadratic formula, but it's not okay with completing the square. Our b is 10, and our c is 2. So I'm going to try to color code this as best as I can. So we're going to start off with the quadratic equation. We want to do the opposite of b, which is 10, so negative 10. And then we want to do plus or minus the square root of b squared, and b again is 10, positive 10, 10 squared minus 4 times a, which in this case is 1, times c, which in this case is 2. And then we want to divide that by 2 times a, which in this case is 1. 2 times a. All right, so now we need to start evaluating it. We start off by looking at what's under the radical. So we start off with the 10 squared, which would be 100. So I'm just going to recopy some of this. Negative 10 plus or minus the square root of 100. Take away, and we can do this all in one step, 4 times 1 times 2, that's 8. Take away 8. All of that divided by, and we can go ahead and do this step too. 2 times 1 is 2. All right, so we still have some information from the radical. That's what we want to keep working on. So we have a negative 10 plus or minus the square root of 92, all of that divided by 2. All right, so we're close to done. The problem here is that 92 has a factor that's a perfect square. So just as a little side note here, we need to know that the square root of 92 is really the same thing as the square root of 4 times 23. And then, since the 4 is a perfect square, we could even further simplify this as 2 times the square root of 23. So we're going to now pull that out beside here. So we have a negative 10 plus or minus 2 times the square root of 23, all of that divided by 2. But we're not done yet, because there's one more step. We should notice that we have a 2, a 10, and a 2, all of which are divisible by 2. So we can factor a 2 out of this situation. So when we factor the 2 out, we are left with a negative 5 plus or minus 1 times 2 would be 2, so just the square root of 23. Negative 5 plus or minus the square root of 23 is our answer. So why don't you guys try this one and this one. All right, let's look at a complex 0. All right, so in this situation, it's 2x squared minus x minus 2. And it's already written in standard form, so I don't have to worry about rewriting it. And I'm going to go ahead and color code it for us. It's 2 is my a, so 2x squared minus x. My coefficient here is 1, or rather, excuse me, negative 1, since we're minusing 1, since we're subtracting 1. And then plus, and then my c is going to be 2. All right, so first step, we need to do the opposite of b. And we need to remember that this is really plus a negative. So the opposite of negative 1. So the opposite of negative 1 plus or minus the square root of b squared, so that's negative 1 squared, minus 4 times a, which is 2, times c, which is 2. All of that divided by 2 times a, which is 2. Okay, so again, we want to work on the information under the radical first. So we have the opposite of negative 1 plus or minus the square root of a negative 1 squared would be positive 1 minus, and then since multiplication is next, we could do all this at once. 4 times 2 is 8, times 2 is 16. All of this divided by, and it would be okay to go ahead and do the denominator, 2 times 2, which is 4. All right, so let's clean this up just a little bit more. We now have the opposite of negative 1, which is positive 1, plus or minus the square root of 1 minus 16, which would be a negative 15. All of that divided by 4. All right, we got one more step to clear up here. And again, I'm just going to do a little side note here. We know that the square root of negative 15 is the same thing as the square root of negative 1 times 15. And that negative 1 can come out front as our imaginary unit. So this is I times the square root of 15. This is why this problem deals with complex zeros. All right, so we now have simplified this into 1 plus or minus I times the square root of 15, all of that divided by 4. Divided by 4. All right, let's take a look. Actually, why don't you guys try this one? And here's a little bit of new information for our notes. The discriminant is an important vocabulary word because by looking at the discriminant, you are able to predict how many answers you're going to have. So for instance, the discriminant, if you have, and it's just the information under the radicals. So if you wind up with an answer bigger than 0, you know you're going to have 2 real solutions. In other words, it's going to dip below the x-axis. If you have a situation where your discriminant is equal to 0, you're going to have 1 solution. In other words, it's going to touch at the origin. And then if you have a situation where there are no, or rather, excuse me, if you have a situation where b squared minus 4ac is less than 0, you're going to wind up with no real solutions. They will be complex. So let's take a look at 3 really quick problems to try to figure out what our discriminant is and how many zeros we're going to have. And again, a word of warning, we need to rewrite these so that they are in standard form. So in this, our first step would be to add 7 to both sides. So now we have x squared minus 6x plus 7 equals 0. All right, now we want to look at the discriminant. And the discriminant is just what's under the radical. You'll remember that's b squared minus 4ac. So my b is negative 6. So we have a negative 6 squared minus 4 times a in this case is 1 times c, which is 7. So negative 6 squared, that's a positive 36 minus 4 times 1 times 7 is 28. 36 take away 28 is 8. So since we line up with a number bigger than 0, we know that this equation is going to have 2 zeros, 2 real zeros. All right, so again, on b here, we want to add 9 to both sides to get it into standard form. So we have x squared minus 6x plus 9 equals 0. All right, so first step, we need to do we need to do b squared, so that would be negative 6 squared minus 4 times a, which is 1, times c, which is 9. So negative 6 squared, that's 36, minus 4 times 1 times 9 is also 36. We wind up with 0. So this is a situation where we have one real 0. All right, now let's go to the last one. We need to add 11 to both sides to put it in a standard form. We wind up with x squared minus 6x plus 11 equals 0. All right, so we do b squared, which is negative 6 squared, minus 4 times a, which is 1, times c, which is 11. So we wind up with negative 6 squared is again 36, minus 4 times 1 times 11 is 44. So we wind up with 36 minus 44, which is going to be a negative 8. So since we wind up with a negative answer, we're going to have two complex roots. All right, try this one, and this one, and this one, and we'll see you in class today.